Hi everyone, it's Jason Lowe from Oracle here. Appreciate everyone coming to the second workshop that we've run today. So we did an intro yesterday at the same time where we went through a few things around what is our give, what's on offer, and some of the ways that we looked at the problems with Callan. But today we're actually going to go into, in the second workshop, is let's go into some of the use cases and not necessarily talk about the problems and how to solve them, but how do we actually look at the different subject areas. And we've got Aaron Hoile from our analytics team who does a lot of work across the Asia Pacific region. So thanks, Aaron, for coming on board. And we also got Ryota, who is one of our product managers from the graph, around the graph technology that we've got. Thanks, Ryota, for coming on board. And we've also got Lynn helping out, and definitely be watching the Q&A and helping out, measuring us and just making sure that we're on time. So happy for everyone being here. Not everyone that I know was at the session yesterday, but I just want to make sure that people knew why we're here. And this is a mission statement that we brought out at our last global conference last year. Yesterday, we introduced a couple of things in our introduction and a couple of the services that we have on offer. So what I'll do, Ryota, I'll stop sharing, and one of the things we'll do is get you to run through graph analytics, and then for about 15 minutes or so, and then we'll pop over to Aaron to talk about the data science. So I'll stop sharing and I'll hand it over to you.
Yep. Hi, my name is Ryota. I am a product manager of graph technology of Oracle, and I'm connecting from Japan today. And today I would like to talk a bit about anomaly detection using graph analytics. So how we can utilize graph analytics capability of Oracle, especially for anomaly detection in financial industry.
Paysafe is a world leader in providing our customers with payment options all around the globe. We are very good at the payments that are highly regulated. Dealing with a lot of money means there are a lot of people that want to abuse your system.
Minimizing risk and fighting with fraud is always been a challenge.
You cannot just stop every transaction and say this is a fraud. You have to be very, very, very precise on which ones to stop. So we have to be able to detect and to stop those. On the other hand, we have to provide a good customer experience.
We use Oracle Graph Analytics for analysis of fraud patterns. Our anti-fraud back officers had to investigate really tough cases, sometimes in hours, and now they can do it in 5 minutes. The queries in the analytics run brilliantly fast.
Some queries that we wanted to run were running like for hours or never finished. With Oracle Graph Analytics, it's always below a second. I love it when I'm able to deliver for happy customers. We are able to stop the bad guys. And Oracle has been a very reliable partner.
We feel that sky is the limit now.
Yes, I'm going to talk a bit more about this use case, but basically Paysafe is one of the largest online payment service providers, and they are recently using graph analytics for their real-time fraud detection, which is basically based on anomaly detection technologies.
Fantastic.
So before talking a bit more about the use case, what is a graph database? Recently, Gartner says that relationship analytics is one of the hot topics in AI and data analytics field. And it is also called as link analysis or graph analytics. At the same time, graph database technology is also a very popular and emerging technology in database field. And as you can see, graph database is one of NoSQL databases, which is very popular and emerging. Oracle database, of course, has graph database capability called property graph feature. And why we call this property graph? Because this graph model is also often called property graph model because it consists of nodes and edges with properties like key value pairs, which is called properties. So in this case, airports are nodes, and the relationship that those nodes have connecting flights is an edge. And nodes and edges have their properties, such as this airport is Osaka International Airport and has connecting flight, which is run by All Nippon Airways. All existing Oracle database after 12.2 can use this feature basically for free without any additional license. Graph analytics typically consists of two parts. One is graph-based query and another one is graph algorithms. And this query is called PGQL query, which is very similar to SQL query, but this is for graph. And you can see the clause called match clause here, which is showing the relationship between A1 node and A2 node. A1 and A2 are surrounded by round brackets, and they are representing nodes like airports. And there's a relationship, there's a flight between those cities, right? And Oracle database also supports more than 50 built-in algorithms. For example, community detection algorithm, if you have heard of label propagation, it is very popular. Community detection algorithms based on the relationship. And you might have heard of PageRank algorithms for scoring whether these nodes are important in the network or not, which is developed by Google. And if you have learned computer science, maybe you have learned Dijkstra algorithm to get the shortest path between one node and another node. All these algorithms are supported on Oracle database. So how we can use graph analytics for anomaly detection, especially in financial industry, such as PaySafe and other customers. It is very useful when we can have a property graph model of bank money transfer information. As you can see here, you can have accounts like those blue nodes are bank accounts and which are owned by red nodes customers. So in this case, Alice has 2 bank accounts. And when you would like to know whether there's any relationship between Bob and Charlie, you can easily see the relationship between these 2 nodes. That Bob node is basically sending money to Dave and Alice, and finally the money is coming to Charlie's bank account. So it is very useful for finding hidden relationship using graph queries. And also it is easy for us to have to visualize heterogeneous information as a graph. So even if you don't have a programming skill or even the skills for writing queries, maybe you can see this information and analyze the relationship. Also, recently many data scientists are introducing graph analytics, especially for enhancing machine learning models. When you have, let's say, bank money transfer information, we don't have much useful information on the bank account property itself. like we cannot really predict whether those accounts are fraudulent accounts or not, using the basic information of the bank account, like a name or a branch name or etc. Right? But if you can look at the relationship of the money transfer, maybe we can find those nodes in the hubs. They're the hubs in the network, or they belong to specific community, and etc. So we can create such engineered features from graph analytics and graph algorithms, so that we can enhance the performance of machine learning. One of our customers, PaySafe, in the video in the beginning, they are using graph analytics. And when they have introduced graph analytics, they have been using a SQL language for describing such complex network and relationships to find the hidden relationships. And this is very small, but this is the SQL query at the time, and the performance of that query was not so great. For example, at the time, 20 seconds for analyzing one-day data, but they moved to graph and using PGQL queries, and then now they can run the same query below 1 second, even if it is that the data for analysis is killed, the query performance is the same. They build their own visualization application as well for non-programmer people, and they recently introducing a graph to their machine learning platform, so they can enhance machine learning with the basic graph algorithms results. At the same time, they are introducing a new, more sophisticated graph-based machine learning algorithms, such as deep work or graph convolutional networks. Okay. During this hackathon, if you are interested in, I would like you to try graph analytics for free using our always free environment. I have created one GitHub repository under my own account. And if you look at this account, you will see this. I have described the setup procedure for autonomous database and graph server on free tier environment. So you can get the free tier cloud environment here, and then load the sample data of the bank accounts and their money transfers. Then you can write SQL queries on SQL Developer, but at the same time, you can also load the data to Graph Server, which is also running on free tier environment. And then you can also visualize the graph and try graph queries and try how anomaly detection on graph platform works. Okay.
So Ryota, we do have a process where we have been giving anyone that is part of the event, not just the trial that you sort of made mention, but also just a really simple way of getting access to that. So we've got a lot of the details in the Slack channel help with Oracle. So we will link that back once we start providing some of the details after this session.
Yes, please. I'm gonna post this GitHub URL to the Slack channel. So if you are interested in, please join us and to develop how we can utilize graph analytics for anomaly detection. Thank you.
Thanks, Ryota. Thanks for running that through with us. We do know that there's a lot of people that I've seen in the introductions where they are, where graph, especially that anomaly detection works hand in hand with what we're doing here. So I appreciate you running through that with us.
Wonderful. I'm personally very excited to be involved with a hackathon. We had a lot of fun last time, and I think we've got some really exciting use cases and challenges to keep you excited and busy during the weekend. So appreciate it is a weekend. So we want to make sure that we can be successful and get to the end of this challenge as quickly as possible and get the best solutions possible. So I wanted to show you a couple of the technology approaches that we at Oracle have put together to help you be successful in this challenge. So two services I want to focus on. One of them is the OCI data science service. So this is our Python-based data science service for the data science persona. So again, if you have experience using Python, Jupyter Labs, the gamut of Python-based machine learning, deep learning libraries, this is the service for you. We've also got a bit of unique IP in there, which in the form of the Accelerated Data Science Toolkit, which is an offering that we've put down and incorporated into service. That's a Python library that just helps you load data, train models, and do some of the data wrangling and cleansing. It also has some model introspection, profiling, and model quality functions as well to make sure that you actually get the best model and you can compare that with other models you may build. So again, some good value there. Going back to one of the things Ryota was talking about with the graph that's embedded in the Oracle database, something else that's interesting is we have machine learning functionality and algorithms embedded in the database. And this is something we've had in the Oracle database since 2001. So again, it's a free functionality within the database. But if the data is already in the database, such as it's the outputs of one of your business systems, what we can do is we can actually do that model development, training, and scoring using the database platform. So I'll show you how easy that is to do in the next couple of slides. So what I want to do is just a quick overview of the Oracle machine learning, which is our in-database platform machine learning. So the way we access that in the cloud is we have a Zeppelin Notebook interface. It's really set up to make it easy to collaborate between developer and application teams. We've got a whole lot of example notebooks and templates in there to help get you started. Right now we use a SQL dialect, but in the very near future, we're going to have Python as well. So again, that's an exciting thing to look forward to in the future. And just to show the depth of algorithms that we have within the database, here's an example of some of the more common algorithms that we have here. So not only do we have a range of statistical functions baked into the database kernel, but there are a whole number of algorithms we can do. One of them that will be especially important here is around anomaly detection. So that should help us with some of the challenges. So what I'll do here is stop the slides and actually go and have a look at a notebook session that I have set up. So if we come into the Oracle Cloud accounts, we can go into the database, open that up, and then get into our Oracle Machine Learning Notebook. So if you can see on the screen here, if we set up an account there after we've loaded some data, we can come into the Oracle Machine Learning page. And now we can look at some of the example notebooks that we have here. So again, anomaly detection, fantastic. So there's some great quick start material there. If I jump back to the slides, what does that actually do? What does it look like being able to generate machine learning models in the database? So if we have a look, we create machine learning models very, very easily by having a training set of data where we select the set out that we want to build the machine learning model on. Then we build the machine learning model essentially just by a procedural SQL statement where we pick the model. We've got the claims data set. We're going to give it the claims model. We're going to do a classification algorithm on here. And we essentially, to score the model and actually get the results out, we just write a simple select statement. So this will spit out essentially the results of the model. And what we can do is just do a quick select statement just to look for the top 5 most suspicious claims transactions. So in the example we're going to pretend that we're an insurance company and we specialize in automotive insurance. So we've got a whole lot of claims history going back over the years, and we want to see what sort of patterns do we have in that, and can we actually detect insurance fraud. And once the model is built, the beauty of building it in the database is any analytics application, anybody with access to write SQL, or any application that I've built can easily call that model and invoke that just with a simple select statement here. And here I'm just spitting out the for the past 30 days, the top 5 most suspicious insurance claims. So again, going back to the notebook session, if I come back here and have a look at one of my notebooks, I'll jump into my notebooks. And if I have a look at an unsupervised example here, what I get is I get a Zeppelin Notebook, and it's going to open up in just one moment. And what I get here is I get a few tools where I can have a look at the pre-built example. So I have a bit of my problem statement here, which is important. It's always good to make sure I have a well-defined problem statement. I can have a look at the data. So all the data that I'm looking at is being loaded in the claims table. So if I do a select on the claims table, I get an understanding of what the data looks like. So I can see I've got day of the week, the make of the car, whether it's an urban or rural area, etc. The sex of the driver. Unfortunately, I think we have a lot of our male drivers overrepresented here. So I've got all the information that you'd expect when I sit down and try to build a data model. So if I just do I've got access to some charting and graphics. So again, this is as easy as, hey, we want to select some records from the claims data set, and then I've got a few options of how I actually want to graph that. So these are the fields that are pulled out in that select statement. I decide I want to have a look at accidents by day of the week. I want to split this by male and female drivers, and I want to see how many claims I actually have. So I do the policy number count here. So if I collapse that back up, it lets me get a bit of a start with some data analytics here. So I can see that, hey, yeah, the most accidents are on Friday, and again, male drivers. If I have a look at where the accidents are happening, there's more happening in urban areas. So I can maybe do a bit of analytics on there and just start to get a feel for which features, which attributes within the data are going to have the most predictive power. Like where are these insurance claims coming from? So again, I've got a range of different data visualization options here where I can go through and have a look at my various features and just to get a bit of a feel for the data. When I come down to actually build the machine learning model, we're going to use an anomaly detection technique based around first class SVM. So again, we're going to build a support vector machine. And again, it's as easy as coming into the machine learning building process. I set up a data structure to put my inputs in. What I do is, this is just a bit of cleanup so I can rerun the notebook, but I essentially pass in the types of models that I want to build. So again, I want to build support vector machines. I give it the data set, etc. Invoke all of this. And again, this is documented in the example code, and it builds the machine learning model. So here, the machine learning model that I'm building is listed down here in the next statement. So when I call this statement here, and again, if SQL is not your primary language, that's okay. I'll show you an example in Python in the next session. But for those of you who are familiar with, say, the application developers, data professionals, analysts, or business analysts, again, you'll be more familiar with SQL. I can actually then start to pull out my my scored data, where I have the percent of fraud, well, the prediction for fraudulent insurance claims. So again, I get a placeholder where I'm breaking this down in the age of the policyholder, whether they're male, female, marital status, etc. So again, I'm just doing a quick select with the fraud prediction in here. Again, we're doing a little bit more data profiling, so I can start to get a sense for, based on the now scored data, where am I seeing fraud patterns? Now, where this will help, and again, because this is unsupervised, it means I'm starting off with data, I don't have any labels in there. I can then pass this to an insurance fraud analyst to sit down and actually bring a human into the loop, and they can start going through the findings here, going through and looking at the most suspicious insurance claims every month, or however often their workflow is, and then they can do some extra classification where they can have a look at that, look at the factors, look at the insurance case, and say, you know what, this one, there is fraud here, and then we can start labeling that data, or they say, you know what, bit suspicious, but this is a legit claim, like it's a false positive. So then we can start building up some labeled information, so we can then produce a better model into the future. The flow of this, we're actually build up an application as well. So it's a pretty cool thing to do in a hack, where I can then build an application workflow for that insurance claims analyst to then interact and start building up a much more accurate model. So if you're interested in that, let me know. I'll be lurking in the Oracle help channel of the challenges. So what I'd like to show is the next piece, and like to show you what we're doing for the Python-based data scientist. So again, the other product that we're going to have available is the OCI Data Science Service. And I want to give you a quick overview of what the OCI Data Science Service is. So again, it's really a centralized collaboration workbench for the professional data scientist. So again, it's got the best of open source tools and technology in there. It's based on Jupyter Labs notebooks. We have Python. It's preloaded with popular AI and ML frameworks. It integrates in with your preferred version control tool set. And what it helps to do is helps you, once you've trained and developed a model, you can then deploy that into a model catalog, so you can share those and collaborate with fellow data scientists. It helps you with some accelerated automation in the form of the bundled accelerated data science SDK. So again, a Python library for accelerating the data science process. So again, it helps you with feature selection, feature evaluation, selecting the optimum model to solve your problem, and it assists with hyperparameter tuning as well. And it's not a black box. You have as much control over the output of this as you would like. So again, you can constrain what it's doing and say, look, instead of checking all of these, say, classification algorithms, I want you just to choose from this subset of 5 models and then go from there. It's also really handy if I have multiple models, say I want to train 4 or 5 models, just to evaluate which one's giving me the best results. So what I'm going to do is I'm going to show you an example notebook that we have packaged with this service, where we're actually going to have a look at anomaly detection with the Pyod Python library. So again, it's a really good library of algorithms for doing anomaly detection. So if you're familiar with that, I'd strongly encourage you to get in and actually have a look at this exercise. So it covers a whole range of steps that we're going to do. So I'm just going to give you a quick overview of what the look and feel of this service is, and then encourage you to actually work through this and see if this is something you would like to leverage in your hack challenge. So if we come into the Oracle machine, so if we come back from the cloud, we come back down to our data and AI services, and we go into data science service. And what we do is you can register a number of different projects for a challenge. So a challenge would be contained with a team working in a project, and in there you can have a whole range of notebooks. The notebooks are serverless, so that makes it great. I can start it up and shut it down, change the shape, maybe move from a compute shape to a GPU accelerated shape, depending on the type of problem. But the beautiful thing is it preserves all the work that I've done to that point. So again, there's no infrastructure to manage. So once I fire up and launch that service, we can see it's a Jupyter Lab environment. We've got Python 3. We have a getting started notebook, which tells you what you need to get started with the OCI Data Science Service. So if I fire that one up here, here we go. So again, it creates a new notebook and just gives a quick overview of OCI Data Science and some of the key features we have with the Accelerated Data Science Toolkit. So you don't need to use the Accelerated Data Science Toolkit. You can use whatever Python libraries, scikit-learn, TensorFlow, whichever libraries and frameworks that you're familiar with. But I think it's pretty cool we can mix and match that in with some of the Accelerated Data Science framework as well. So the other thing we can find back at the launches, we have a whole package library of example notebooks. So there's some really cool coding examples in here of how to tackle and approach different problems, use different algorithms, and explore other challenges. So again, really cool. I'm going to have a look at are building the anomaly detection algorithm with Hoile. So if we come in and have a look here, here's a quick overview. I can see, look, anomaly detection experience is preferred, but again, it's laid out and there's plenty of commentary in here to sort of explain what it is we're doing. So we have all the prerequisites, what we do when we access the data. We're going to go to the web and pull down a data set and then take a sample from that data set. And instead of using, say, pandas to stage the data, what we're going to do is actually load the data into the ADS data factory. So again, it's another Python class that's in here, which has a whole lot of automation around loading data, conforming the data, and profiling it. So what I do is I've loaded in my fraud data set. I then run show on notebook, and sort of being pandas on steroids here, we go in and we have a look, and it's done a whole lot of statistics on the data. It's done a lot of profiling. It's got a list of the features as you would expect. But the other one is it profiles the data too and looks for any problems in it. So I can see that because it's an anomaly detection data set, there's very few instances of the anomaly. So it's a very skewed data. And we can see that we have a whole lot of zeros in here as well. So what we're looking at is a classic anomaly detection problem. We have a very imbalanced data set. So we're doing a few data correction steps here. And then we're going to have a look at what the target is, and we want to be training a model to detect the anomalies that we have in our data set. So it's quite nice. It is a cybersecurity data set from Oracle. So again, it's nice to actually be able to look through, hey, what are these penetration attempts into a cyber network? So if we come down and have a look at this, we do a little bit of data correction and fix up some values. We're having a look at the skew of the data, and we can see we have very few instances of anomalies. Most of it's not anomaly. So again, these produce slightly different challenges to a standard machine learning model build, where I may be doing something like classification or regression. So again, lots of automation in here for producing these plots. So once I set the target, the data factory service actually goes in and produces this for me. So I get a head start on my data profiling. So just a few lines of code, I'm down to there. What we want to do is actually split the data of test and train. So again, pretty standard. We're doing a little bit of data exploration to actually pull out what these anomalous records look like. And what we're going to do now is, again, a bit of a read up for those who are new to anomaly detection. It runs through a whole lot of the typical algorithms we might like to use, gives a bit of an explanation and overview within this notebook. What we do is we're actually going to build up several different algorithms here. So we're going to build an isolation forest model. Here we're building a KNN model. We're building a random forest, just using the scikit-learn library. For those of you who are more familiar with the scikit-learn. And what we're going to do is then do a comparison. So once we've built all those models, what we're doing is we're going to pass them into our model evaluation accelerator. So here we create an ADS evaluator, and we pass in all the models that we've built. We pass in our test set of data, and what we do is we ask you to compare all of these models. So again, because it's an anomaly detection use case, we might say that when we look down at the lifted gain, the ROC charts, the confusion matrices, we see that the random forest actually does quite well. But when we come down and have a look at the F1 score and the accuracy, we can see, well, it's not as good as the isolation forest. So again, it's a really quick way of quickly building a range of models and then seeing which one's going to give the best accuracy. And we can measure that accuracy over a whole range of scoring methodologies, depending on what it is we're trying to do. So a little bit more information here about the cost of the model. We also see that the isolation forest is actually computationally less expensive than the other methods as well. So not only is it very accurate, it's also relatively cheap to run as well. So again, other considerations. Once we've built the model, obviously we can use the ADS toolkit to actually go and deploy that to the model catalog. So then it's ready to deploy into a business process to actually put that to work. One of the other interesting things we can do is, now that model becomes a black box model, we can actually do some feature importance and test the model accuracy as well. So there's a range of other functions built into the ADS library to pull out feature importance, etc. So again, it's really interesting. I'd strongly encourage you to get in, have a look at some of the examples, have a look at this anomaly detection method here. Again, if you're thinking of taking a Python-based approach, I would encourage you to have a look at the Python within the Oracle OCI data science service. And again, we've got plenty of other tutorials, documentation available. So hit me up. I'll post these links in the Slack channels, and it'd be really exciting to do some work with the OCI data science or the OML in database machine learning libraries. Thank you very much.
Thanks, Aaron. Great run through both yourself and Ryota. One of the things that I do want to bring up now is some of the work that we've been doing today in terms of getting prepared for the session. So Aaron, can you just walk through in terms of what we've got, what we've been able to provision up, and maybe something that may entice some people that actually can probably extend themselves and do a little bit more with it?
Yeah, absolutely. So again, this is something that I'm very excited to announce. We have secured a range of GPU compute shapes to be handed out to teams undertaking this challenge. So again, if you're pursuing an approach to one of these challenges that lends itself to GPU acceleration, maybe using a deep learning approach, perhaps it's the deep fake recognition, or we're using a deep learning approach to anomaly detection, you may benefit from having a GPU accelerated shape. So again, we have GPUs that are available to underpin the OCI data science service. So again, that was the Python service I was just showing you, as well as if you say, look, I'm really familiar with my own frameworks, you want to bring your own virtual machine and run that on a GPU shape and install your own libraries, you're welcome to do that too. So in addition to the OCI data science service, we do have a data science virtual machine with Anaconda, TensorFlow, Keras, a whole lot of other deep learning frameworks and libraries pre-installed. So that's something else you could take advantage of. So please reach out to Jason or myself, and we can look at making these GPU accelerated shapes available to you.
Yeah, so we've been very we've been working behind the scenes to actually get that available. It's not available everywhere, so I think this is a unique situation where we can offer that to a small group of teams. So we will be promoting that in the Help with Oracle channel in terms of how best to put your team forward to actually get access to this. So in addition to that, and it's probably something, I know my screen's not the best of times at the moment because it was cutting in and out. One of the other things I do know that looking through the introduction, I did notice a few blockchain people with blockchain experience and the like in terms of actually working that. So we've been able to also secure a few instances of the Oracle blockchain already provisioned up and running. So very similar to the GPU, if you're in and doing a blockchain style approach and you want to, instead of build your own stuff and actually get involved and just start building out your chain code straight away, then we've got actually all that provisioned already to get started. It's not cheating, it's called using the resources that you have at hand. So what I'll do, I know we're probably a little bit early and that kind of thing. Q&A, then any questions on the chat that you see?
No, but if anyone wants to ask us a question, just pop it in the Q&A panel and we can answer it for you. And also don't forget that the Slack channel will have all the information for you.
So all of this will be has been recorded. So I've got that. We will publish that out there. Ryota's got a PDF version of his slides available, so we'll put that into the Slack channel as well as the PaySafe video that you showed right at the beginning. We've already got that up there as well. So if you want to go back and have a look at what they're sort of doing, then that's fantastic. and we will put up onto the Slack channel any how to, if that GPU is something that is worth putting to work for you as part of your team, then we'll definitely put that into the Slack channel as well.
Hey, fantastic! How exciting!
Great.
It's very cool. It was very easy to get up and going. So it was only.
You're a first-time GPU instigator too, right, Jason? This is your first time building accelerated data science platforms?
Yeah, so
we had everything up and running in 20 minutes.
Well, yeah, the GPU VM from the marketplace, I was able to get into my tenancy and up and running, and a Jupyter Notebook there within half an hour. So that was pretty easy. The Data Science Cloud was equally as easy once we got the tenancy up and going. So there's no reason why you shouldn't consider these tools, especially from a GPU perspective, or in some of these tenancies, we can definitely have more CPU than you probably have on your laptop. Then it's definitely something to take advantage of. So you actually, so that's the on our Oracle Cloud Marketplace. So cloudmarketplace.oracle.com. Clicking the Get app and then pointing that to your tenancy, it does the rest of the work underneath the hood in terms of configuring that up. There's probably a couple of steps in terms of starting up, at least that one, starting up the Jupyter Notebook and putting some keys in, but yeah, a few lines in there, and then you've got your Jupyter Notebook session up and running. So it looks like we don't actually have any questions, but as I said, we are all here to help out over the weekend. Ryota, Aaron, any last comments from you? Len, any last comments? Ryota?
Well, see you on Slack.
Yeah. Aaron?
I think we've got some fantastic challenges. There's some really cool ones that lend themselves to machine learning. So I'm keen to helping you guys be successful with these challenges. So please seek me out on the Slack channels.
Cool. And Len, anything else from you?
No, we're here to help everybody be successful over the weekend. That's the most important thing. Whether you use our tech or someone else's tech, we're here to help you out.
Fantastic.
Really, you know.
Thank you for your time today, Ryota, Aaron, Len, and everyone online. Appreciate you taking the time out of your day. I can see the thank you. Hey Sam, how are you? Very cool. I'll see you on the Slack channel, and we've actually got our next session with DJ and Franco coming up in about 75 minutes time. So we'll see you soon. Bye.
Great stuff. Bye guys.